So section 4.3 is kind of like 4.2 a little bit. We're going to talk about congruent figures, but do you remember yesterday we just talked about general congruent figures? I think we did, what, a hexagon, right? We talked about that first. But I said eventually later on in this chapter, you're going to be talking about not just congruent figures, but congruent what? What kind of shapes? What kind of shapes? I'm trying to talk. Just put them down. Just put them down. No, I said the rest. We already did a hexagon. I said yesterday we talked about. Wait until. So yesterday we talked about congruent figures. We said you could have whatever sides. Okay, we showed a six-sided figure, right? A hexagon. We talked about that. But I did say that more specifically, the rest of the book or the rest of the chapter, we're going to be talking about congruent what kind of shapes? No. Congruent what kind of shapes? Triangles. Triangles, okay? Watch the video. I said it, okay? We talked about circles yesterday, though. But I didn't say the rest of the chapter we're going to talk about circles. So what we're going to do is going to put a triangle here. Everybody write this down. Draw this triangle. I'm going to make it look about like that. All right? And what I'm going to do is I'm going to label it. Let's try this one more time. Okay, I'm going to label it, for lack of ingenuity, I'll just call it ABC. Now, what I'm going to do is I'm going to copy and paste. So by me copying and pasting, what do you think is true about these two triangles right here? They're congruent, okay? But you know that problem you asked, Makai, about that first, that number 1? It said which triangles appear to be congruent. We cannot just go by things appearing to be congruent. We can't just say, well, it sure looks like it. What? Yes. Anybody else want to do anything? I mean, picked a great time to go do stuff right when I'm trying to start teaching. Get a tissue. When I'm done. All right, here we go. I did copy and paste this, so you do know that they're congruent to each other. But if all you did was just saw this on the screen, I didn't say I copied and pasted it. It looks like they're congruent, right? Can I just say, yeah, they're congruent? No. What I'd have to show is this. Until today, listen. Until today, like as in yesterday, in order to show that they're congruent to each other, I would have had to show that this angle and this angle were equal. I'd have to show that this angle and this angle were equal, and this one and this one. As of yesterday, that's still not enough. How many parts do we have to this triangle? We don't just have 3 parts, the angles. What else do we have? We got the 3 sides. So I'd also have to show this. I'd have to show that this side, BC, is equal to this side, EF. I'd also have to show that this was equal to this. And then I'd also have to show that this and this were equal. So before today, listen, before today, I would have to show 6 things on this triangle equaling 6 things on this triangle. But today's going to be a little bit different. Okay. But today, this is a little bit different because I'm going to show you an easier way to show these triangles congruent. Okay. I don't have to show all 6 things because today we're going to do let's see, I always forget if it's a theorem or a postulate. I think the first one, yeah, is a postulate. Okay. We just accept this without proof. That's what a postulate is. Remember we talked about that a while back? Okay, a postulate, you don't have to prove. A theorem, you what? You do have to prove, okay? Now, in this class, I decided when I first started teaching this class that I'm not going to do proofs in here, okay? So we're not going to have to prove anything. But in the geometry world, though, a postulate is just an accepted fact. We just accept it as fact. There's no way to prove it. It's just true, okay? But a theorem is, it looks like a postulate, but it has to be proven, all right? So let's do this. Let me get rid of all these marks. Control Z a bunch of times. There we go. All right, so now we got two triangles right here. Let me show you the first thing. The first thing says, if I can show that one side is equal to another side, and if I can show this angle is equal to this angle, now that's not enough to say that these triangles are congruent, okay? That's not enough. But if I show one more thing, if I show that this side is equal to this side, that's only three. That's half of what we had to show before. It's only three things. Now I can say that this triangle is congruent to this one. So if you tried to draw these two sides equal, have an equal angle in between, and have these two sides equal to each other, that's this side right here is always going to, or this triangle right here will always be congruent to this triangle. You see that? So I only had to show three things. I had to show a what? What do I call this AC? A side, right? So I had to show a side. I had to show a what? An angle. And I had to show what else? Another side. Good. Okay? Everybody with me on that? Now, this angle is in between these two sides. Everybody see that? I can't just pick any random angle in this triangle. The angle that I pick has got to be in between these two sides. We call this the included angle. We'll use that word from time to time, so I want you to know what it means. It's the included angle. It means it's in between the two sides. Would you agree? Because this side has this angle as part of it, and this side has this angle part of it. Does this side right here, AB, does that have this angle a part of AB? Not at all. Okay, AB has nothing to do with this angle right here, does it? But BC does, right? Because BC makes up part of that angle. And then AC makes up part of that angle. Okay? Everybody with me? Okay. So here's what I call it. Now, these sides over here have to be corresponding. Now, I didn't take this triangle and flip it and all that kind of stuff. I just copied, pasted it, stuck it right next to it so it looks exactly the same. All right? I didn't twist it. I didn't flip it or anything like that. So these are the corresponding sides. So if the corresponding side angle side over here equal the corresponding side angle side over here, then these triangles are congruent to each other. We have a name for this postulate, and it's called the side angle side postulate. Okay, let's write that down. But we don't have to write those words, side, angle, and side. Guess what we're going to do? We're going to shorten it to what? Yep, we're going to go side, angle, side. Now, we don't say SAS, but we just say side, angle, side. All right? And we don't say SAS, we say side, angle, side. So when I write it like this, because I could have questions, and I will, on the quiz and on the test, I will have questions that say, why are these triangles congruent? And I give you that stuff. I give you those sides and that included angle. And then I'm going to ask you to, first of all, write a congruency statement. We talked about that yesterday, right? We did those yesterday, the congruency statements. So I'm going to say, write a congruency statement and give me the reason why those triangles are congruent. So if I gave you this on a quiz or a test, all right, forget all this. I'll tell you what, let's clean this up just a little bit. Let's get rid of this. Let's get rid of this, and this, and this, and that. All right? And let's just get rid of this as well. Okay, so here could be a question on a quiz or a test. Not could be, it will be. Maybe not the exact same looking triangle, but it'll be something very similar to this. Everybody with me so far? So this could be a question, or it will be a question on a quiz or a test. I'm going to give you these two triangles. This is the given information. They tell you, all right? I can't just look at it and say that AC and DF were equal to each other. They had to tell me specifically that AC and DF were equal, BC and EF were equal, and angle C equals angle F. They told me that on the test. Got it? The question is, name a or write the Write the triangle congruency statement. Okay? Write the triangle congruency statement. What does that mean? That means I'm going to write a little symbol for triangle. What do I want to call this triangle over here on the left? Just call it ABC. That's easy enough, isn't it? Did you have to call it ABC? No, I could have called it something else. What else could I have called that triangle on the left? CBA, right? I could have called it CBA, or I could have called it ACB, or BAC, or BCA, or a whole bunch of other different options. Agreed? I decided I'm just going to call it ABC. Keep it in alphabetical order makes it easy. Now, come over here. I'm going to put a congruency statement. That's an ugly looking congruence, isn't it? That's equals, and then that looks a little bit better. Now, it's very important. I made this super easy. It doesn't get much easier than this one, okay? I made it super easy. But which one corresponds to angle A over here? D. How do you know? Because A's where? A's on top, D's on top. But you got to be careful, though. I'm going to give you a huge hint here, so I hope you're watching and paying attention. Because on the test and quiz, I may take this triangle right here, I may take it and twist it, okay? And so you're not going to, and I might flip it, okay? So sometimes it's really hard to look at it and say, oh, which one matches up with what? Because look, D and E kind of look about the same angle, don't they? What if I took it and I flipped it? You wouldn't know if it was D or if it was E, right, that was equal to A or B over there. So here's how you know which one it is. Look what side is opposite angle A. So which side on this triangle is opposite angle A? Everybody look up here. I got like half of you looking up here. Look at angle A. Which side is opposite angle A? What side? BC. That's right. You see it? Here's A. Go across from it. You see it? Okay, go right across from it. It's BC. Everybody with me on that? And it's the one with the 2 marks on it, the two tick marks. Which one over here has the 2 tick marks? This EF, right? And what angle is opposite EF? Angle D. So if A is opposite BC and D is opposite the equal side, then A and D have got to match up. You see what I just did? So A and D have to go together. So what's going to be over here? Put triangle, put D. All right? What about B? What side is B opposite? Then AC. And that's got the 1 tick mark, doesn't it? Come over here. Which one has the 1 tick mark? DF. What angle is opposite the 1 tick mark? Angle E. So B and E correspond to each other. They're the ones that match up. You see what I'm doing? On this one, it's super easy. I mean, look, I could look at this and say, oh, the A and the D are in the same spot, the B and the E are in the same spot, and the C and the F are in the same spot. That's easy. But it's when I start twisting, right? I take that and I twist it, and then I flip it, and maybe flip it upside down, and then you get really confused on which one matches up with what. It's hard to tell sometimes just by looking at it. So what do? You look to see what side or what angle that thing is opposite, okay? So A is opposite the 2 tick marks. D is opposite the 2 tick marks. That means A and D correspond. They go together. So the A goes first, the D goes first. Okay? The B is opposite the 1 tick mark. What's opposite the 1 tick mark over here? The E. So the E goes next. Now what's opposite? Look at the C. The C is the one with the 1 arc. So which one over here has the 1 arc? The F. So the C and the F go together. Does that make sense? You see that? All right. Again, I'm repeating myself, but these two are really super easy to do because you can just kind of look at them and see which ones match up, right? If I took this up, if I took this one, picked it up, and put it right on top of the other one, you could very easily see. But what if I did this? What if I took it and I turned it a little bit? Then sometimes it's going to be hard to see, oh, which way should I turn it to make sure they match up with each other? Sometimes it's hard to tell. So this is a good way to tell which ones match up with each other. Make sense? Check on him, see if he's all right. Okay? Now, that's the first part of it. So I'm going to ask you to do 2 things. I'm going to ask you to write the congruence statement. Okay? Everybody look here? Okay. Did he take the can? Or is it still? He did? Okay. So watch. So look. Now, here's the next part of this question. I'm giving you quiz questions and test questions right here. So I hope you're watching. So I'm going to ask you to write the congruency statement. That's it right there. So that's part 1. Then part 2, I'm going to say, give me a reason why the triangles are congruent. And that's what we just finished talking about. So what is it? Boom, boom, boom. What is it? Why are these triangles congruent to each other? It's 3 letters, guys. It wasn't that long ago. Yeah, but we don't say SAS. We don't say SAS. Side angle side. Wow. Got a reaction out of you now, didn't I? You guys all woke up at the same time. All right, so side angle side. That's what we say. We don't say SAS. We don't say SAS. We say side angle side. That's what we say. No geometry teacher ever has said SAS on this, okay? We always say side angle side. All right, let's do one more, okay? There's two of them we're going to do today. There's more than just two, but there's two that we're going to do today. What? Yes, after I'm done. All right, let's do another one. I'll tell you what. Let's just pick the same triangle. I'm not being creative. I only got a couple minutes here anyway. So there's one more that we're going to do. Again, I don't know. Let's try different letters. P, Q, R, and then J, K, L. There's paper towels right there. Just use paper towel. Here's another postulate. Here we go. One more postulate. And then tomorrow we're going to do theorems. So today's another postulate. Let's write that word down. Postulate. Here's another one they're going to give you. Everybody watch. Let's say they give you that angle Q is equal to angle K. All right? And let's say they tell you, again, they're telling you this stuff, okay, that QR is equal to KL. And they tell you one more thing. They tell you that angle R is equal to angle L. Okay? Wayne, don't bring that in here. All right, so here we go. Are you all right? Okay. Did you go to the nurse? Did you go to the nurse? All right. All right, so here we go. So everybody look at this. With what I just showed you right here, with what I just showed you right there, this is another postulate. What do you think this postulate is called? It's not side angle side because I only have one side. Angle, side, angle. That's right. So watch. It's angle, side, angle. Angle, side, angle. So that's two postulates that we did today. So you do have a homework tonight. It's on your sheet. If you don't have it on the sheet, I'll write it down. It will be on the video after I write it down. So what is this? 4-3? Yeah, it's 1 to 15. Now watch. It's 1 to 15. I gave you a few extras, though. 20 to 23. Okay, 1 to 15, 20 to 23. This page is 165, 166, and it's section 4-3. That's the homework.